Hello everyone, thanks for joining in. Today we will discuss ISIS protocol that performs intermediate system to intermediate system. So today we will discuss the topic importance of ISIS, overview of ISIS, history, objective of CLNS model, how ISIS works in between same network and between two network, objective of ISIS, and last TLB. So let's move on our first topic, that is importance of ISIS. So as we know that the very important technology in data center is ACI. So underlay protocol that we use is ISIS itself. And in SDA, that is software defined access network. So in that as well, we use ISIS as an underlay protocol. So now ISIS overview. It's an IGP protocol like we have EIGRP and OSPF. It has a lot of good things which are over OSPF as a protocol. So that part we will discuss in the next few minutes. So both ISIS and OSPF are standard and link state protocol, and they do work on exchanging LSAs with each other, and based on that every router in an area would form a full topology view and learn the best route. So now let's discuss the history of ISIS. Actually, it will help us to understand the configuration and terminologies of ISIS. So long time ago, if we talk about before the internet, so there were a lot of vendors that were putting out their own networking infrastructure for doing networking. So there were big players such as Novell, Apple, IBM, DEC. DEC full form is Digital Equipment Corporation and Department of Defense. So all these players were using their own protocol. Like Novell was using IPX XPX protocol suite, Apple was using Apple Talk suite, DEC was using their own DNA model, and Department of Defense was using IP protocol. So Department of Defense had their own model for doing networking that was eventually won the war of network connectivity, where that became the main model, right? That is our IP model that we use today. So IP was used in banks, universities, defense at that time, only in government areas. So every company had their own way of doing networking, but they are all completely different. So DEC was the first company that wanted to create an open model so that each company's devices can talk to each other. So they came up with a model called CLNS model. That's performance connectionless network service model. And that model has ISIS setup. So this is where ISIS came from. So it was the open networking architecture for CLNS. So before the internet, there was an attempt by ISO, that performs International Standard Organization. They came up with a model called OSI model, but it was a more of a reference model. So it was not actual implementation there. So all the story was before pre-internet, right? So in 1990s, Novell was the biggest company in networking. So we can say that about 70% of the LAN network was Novell based. So when the internet came, then Novell said, no, no, everyone needs to adopt my network. I am the leader of networking. But what happened that internet became so popular in very short time. So it was running the IP model. So everyone wanted to connect to the internet. So slowly, all the other model made way for Department of Defense model. So the CLNS model along with the other ones thrown away, right? So in CLNS model, one of the main protocols that I said was ISIS. So it was a great protocol where a lot of engineers at that time thought this is a good protocol to incorporate into IP model. So they took the capabilities of ISIS from CLNS and incorporated that into IP model, right? And initially they used to call it the integrated ISIS because it was integrated from CLNS model into IP model, right? So let's discuss the objective of CLNS model. Their objective was to basically to be an open model for communication, and they had different type of communication. So if I talk about same network in OSPF and EIGRP, we call end devices to computers, right? But in ISIS, we use the term end system for computers and desktop. So if we want to make communication between two end system, then we will use CLNP protocol. And if we have two different network, right? And if we want to make communication between two router, then we will use ISIS protocol. So here the name of router is intermediate system. And if we want to make communication between end system and intermediate system, then we will use ESIS protocol. Okay. So let's discuss the objective of ISIS. So to exchange information between two devices. So when it was written, there was no L2 or L3 concept. It makes a little different than the other protocols that we had, we can say. So here we can understand how ISIS is far better than OSPF protocol. So as I discussed that ISIS can exchange any information, but OSPF, actually if I talk about OSPF version 2, so their algorithm was written to exchange the only IPv4 routes. When we started using the IPv6 addresses, then OSPF version 2 was failed because it was not supporting the IPv6 routes. So again what happened, that engineers wrote the once again the algorithm in OSPF so that it can support the IPv6 addresses. So later OSPF v3 comes in our network. So after that we started using the OSPF v3 for IPv6 route. But there is no such restrictions in ISIS. ISIS was written to exchange information, right? So in OSPF, as I said, payload was designed in the standard that the information that I am exchanging 32-bit route along with its attributes. So in ISIS, the standard that was written that is allowed to exchange routes based on this field called TLV, that is type length value. So in type, we'll have to, or we can say to inform to ISIS that what type of information we want to exchange. Either it's hexadecimal or decimal, right? And in length, we'll have to tell ISIS that this is 128 bits or this is 38 bits, 32 bits, sorry. And in value, we'll have to specify what information we want to exchange. So due to this, ISIS is very flexible and it could exchange any type of information without having to rewrite the algorithm. So that's the main reason why that's why Cisco picks ISIS as a delay protocol. So in IP model, this is very important line. In IP model, the integrated ISIS communicates at layer 2. So it sends addresses based on MAC address. But the information it exchanges over there, that information is could be layer 2 or layer 3. So it could exchange any type of information, right? That I said before. So now just like we have public and private IP addresses, Digital Equipment Corporation also thought the same thing at that time. So they dedicated two hexadecimal digits, that is from range 39 to 49. But nowadays actually we are using only for private, and we are using only 49 in maximum cases, and few cases we are using 47, right? But yeah, we can use all the ranges in our networking. It should work. So as I said that ISIS is a link state protocol. So ISIS uses the same concept of full view of network by exchanging the LSAs, and that logical group is called area. So ISIS also broken down in areas just like we have in OSPF. So as we know that if we want to exchange routes between two areas in OSPF, we use ABR router, right? But ISIS is different. Router is completely within an area. There is no router that has two areas that it belongs to. But in OSPF, if we talk about the ABR router, it has one link in another area and one link in different area. But in ISIS, there is no such things. A single router will be completely within an area, right? So this is the difference between OSPF and ISIS. And the next difference is, if I wanted to compare that, what type of LSAs will be propagated within an area over here. So in an OSPF, in the same area, we use LSA1 or LSA2, right? But in ISIS, we have only one LSA, that is level 1 LSA in the same area. And if you want to exchange the routes between two area, then we use LSA3 in OSPF, right? But in ISIS, we use level 2 LSA if we want to exchange routes between two area. And in OSPF, there is area 0, right? But in ISIS, there is no area 0 concept. And the difference, that external routes actually type 4 or type 5 in OSPF, right? So we use the different LSAs like LSA4, LSA5, LSA6, LSA7. But in ISIS, only two LSAs, that is LSA1, level 1 LSA, and level 2 LSA, that is LSA2. So today was the agenda, that topic I have covered. So in the next topic, we will cover the practical part. So I hope guys you have learned something new. So till the next video, I am signing off. Take care.